This video should help in designing the amplifier for the project number 2, which is to replace the operational amplifier of 101 volt per volt gain with a single input MosFet amplifier with multiple stages. So the first step to do is to pick the actual configuration that you want to do for the MosFet. So in the lab you did this type of a configuration where you biased the gate by 2 resistors, and then you had RD and RS. Another configuration would be, instead of RS, you could bias the transistor using a current mirror. So either configuration will work. I'm going to go over this one, which is the one you did in the lab. So the first thing is to use the rule of thumb that was described in the lab, where VD is approximately a third of VDD. So in this case, that would put VD at 5 volts. And then the same thing for VS, approximately a third VDD. VDD is 15, so again, VS would be put at approximately 5 volts also. So these are a ballpark figure of where to start. Now, knowing the voltages, once we find the current ID, you can solve for RD and RS. So once you figure out the voltages that you're going to have, we need to figure out what ID is going to be. So ID can be found using an estimate for the gain. So looking at the small signal of this, you can redraw the small signal. I'm going to erase this. So the small signal, redrawing it, and ignoring RO. My V out is going to be taken here. And so V out over V in, or V sig, is going to be the minus GM VGS times these two, and then VGS is across here, will be a voltage divider here. So I get the minus GM VGS RD in parallel with RL, and then VGS is V sig RG1 in parallel with RG2 all over the summation of those two plus the R sig. So for your circuit, where does the RL and the R sig come from? Since this is going to be the circuit, this is where your microphone comes in. So this is where your microphone. And your load is going to be the next stage, equivalent resistance. So if we were able to do this in one configuration, then we would need a gain here for this op amp of 101 volt per volt. And the RL would be approximately 10K. Remember, it's going to the potentiometer into the next op amp, which has a high input resistance. So approximately 10K. Here this is coming from your microphone, which this is going to be approximately 40K because of the 47K in parallel with the 100K from the microphone part of it. So these are just estimates. So now I can take these equations, I can set a gain of 101 and then I can design this. So GM I can write in terms, I have two equations. RD can also be written in terms of ID. So we have the square root of 2 kn prime w over L ID. And RD can also be written in terms of 15 minus VD all over ID. So I can set this as 101 volt per volt here, and it can be negative. Remember, this is only going to shift the phase, not the gain. So I can set this as a negative 101, and therefore they'll cancel. And then I can put this into MATLAB or use an Excel spreadsheet, and then I can sort of play around with these values. So doing that, I saw that it's going to be really difficult to get this to be 101 volt per volt gain. I'll show you in a minute what I did for the spreadsheet. The Kn prime, this is going to be the value that I measured in lab for my actual transistor that I'm going to use. And you also measured VT in lab, and that's going to also be used in your equations. So the equations that I'm going to use in the spreadsheet now, summarizing those. So my measured value, VT is also your measured value. Okay, I'm going to use R sig, it's approximately 40K, RL is approximately 10K, and VD I'm going to set at first at 5 volts and VS at 5 volts. Then I'm going to use those equations. So I know GM RD, it's my VDD, which in this case I used 15. And then my gain equation, I'm just going to leave it positive. Okay, so the best case I can get out of this quantity is going to be approximately 1. So I'm going to estimate this as approximately 1 so that will simplify it here. I can then look at the load not making much of an effect, and therefore just concentrating on this term. I can get GM RD, and GM can also be written as 2ID over VGS minus VT, and then RD can be written as this, and this will simplify down, then I can have just one equation with just VGS in it. So then I need to make sure as I'm doing this that my VGS is still always greater than VT. So always check that VGS is greater than VT, and that VDS will always be greater than VGS minus VT. So these conditions always have to be checked to make sure that they're going to work.